What if we want to calculate the distance that an object has traveled, and we know the speed at any given time? In other words, we perhaps have a graph of the speed versus the time. And so we can say for any time we're interested in what the speed is at that time. How far did this person travel in 10 seconds, for instance? Well, imagine we took measurements every 2 seconds. And then we used rectangles to approximate the distance that the person traveled in 10 seconds. And maybe we took measurements every 1 second, and we would get something that looks like this. And maybe we took measurements every half a second, and then we would get something that looked like this. And you can kind of see what's happening here. More rectangles means better estimate of the distance traveled. But more rectangles also means a better estimate of the area under the curve. So I think you get the idea. The distance traveled is the area under the curve. So when we're trying to calculate the distance that an object has traveled, and we have some kind of function representation of that velocity versus time, we can find the distance traveled by just finding the area under that curve. In general, one of the big problems in calculus is, given a function, how can we find the area under that curve when we graph that function? And that is a very important problem to try and understand.